Hello. One question up front. Who was here in this talk last year? Okay, only very few people. That's good because I have a little so some slides are copied from last year, just to give an intro into the topic. So, overall, what's SMB3 Unix extensions? Essentially, what we want to do is, in drastic words, kill NFS. And that's a very drastic. I know this won't happen until I retire, but what can you do? So why? So in my world, we have two dominant file system protocols. The one is NFS, and which is native and historically native to Linux or Unix or Solaris or AIX or whatever. And there's SMB, which comes from the Windows world. And NFS has really native support in all Unixes, in all Linuxes. It's pretty simple to set up initially. You just edit some files in etc export or add some lines in etc exports, and it just works. So you don't have to think about authentication. You don't have to think about security, nothing. It just works, which is very, very handy for simple setups that, you just want to quickly set up and so on. It is reasonably compatible with what Windows applications expect. It's not 100% local coherent. One particularly bad example is how to delete open files. I hold a file open, I delete it, and in a local file system like ext4, it just disappears from the namespace. The data is still there. It will still be held. In NFS, NFS has to play tricks and rename that to .nfs and then some long number, and just for the file to still be accessible while it's still open on the client. In plain NFS, metadata caching is particularly bad. So one example is the file M time. There are applications which depend on the last modification time to be accurate, and this just doesn't work over NFS just because always, if you want to do a stat, the M time can always change, and you need to do caching, and there is no coherent caching mechanism at all. Then file locking doesn't work at all, for reasonably okay. I can't say it doesn't really work at all, but it has very bad corner cases. There's a huge discussion about, or there's a huge section in the NFS v4 RFCs, how to make locking work. How does the server notice when a client is gone? How does a client notice when a server is gone? How do we retain locking state? How do we re-establish locking state if both are back? A lot of work. Next point, there is no file security. And in general, I mean, yes, you can make it secure with Kerberos, but I have yet to come across a scalable or scaling a large deployment where you have Kerberized NFS and people are happy with it. That combination is the piece that makes it difficult to achieve. SMB, on the other hand, also similar goal, just share files and directories. And very similar goal from like 10 miles above, with some differences. It's secure by default in any sense that you have authenticated connections. You can easily just enable transport encryption. Transport signing is mandatory anyway for a few releases now of the SMB protocol. So it's in the default installation, it's much more secure from my point of view than NFS is. Then you have a decent mechanism for cache coherency. I know that NFS v4 something added direct releases, added leases, and they call it delegations, but it's not implemented everywhere. So SMB has all this really embedded into the core protocol, and everybody just implements it. Locking works in the protocol as such, and this is because Microsoft has to be compatible with local applications. And you can say a lot of bad things about Microsoft, but they are really good at one thing, which is application compatibility to the core OS. This means they have to make logging work, and it just works across the protocol. There might always be problems, of course, with implementations, but the protocol provides good logging. And yeah, servers just are everywhere. And if you just read a little whatever intro, it's not really much more complicated than setting up etc exports, adding a line there, and the server will just work. Of course, you have to take into account the secure by default. You have to take care about users and groups. But yeah, this is a downside of NFS, I would believe. So, in my world, NFS is pretty arcane. And I come from the SMB world, of course. So take this with a grain of salt. We want to make SMB a competitor to NFS. What does that mean? There is, of course, the Linux client by Steve French, where you can mount SMB shares, but they have severe limitations when using these clients against native SMB without these extensions. In particular, and this is what I'm going to talk about, we have file name handling, we have POSIX metadata, and we have special files. You want to run your SSH agent, you want your SSH agent on your client to open a socket where your home directory is on sys. Or, yeah, SMB, mount.sys, it's still called mount.sys. When you have your home directory on SMB, you want your SSH agent to open a Unix domain socket, and that has to live on SMB. And this is something plain SMB doesn't do properly right now. How do we do this? The SMB2 protocol is really open. It was designed with extensibility in mind. The first thing we do is we call it negotiate protocol. Client tells the server, hey, I have these capabilities as the first packet, completely unauthenticated. First packet is, okay, I want to speak this version, I have these extensions, and so on. Please, server, tell me what you can do. And as a client, we offer the ability, hey, we are speaking POSIX extensions with a negotiate context. That's what it's called technically. Server tells us, yes, I know these extensions, and it answers properly. If it doesn't do that, it just ignores this request, and we can now figure out, yes, the server can do POSIX extensions. What would that activate? That would activate that when we deal with file names, we are privileged, or we can send a so-called POSIX create context. So server tells us, yes, I know POSIX. And then when we open a file, when we stat a file, essentially when we look up a file name, we can tell the server, yes, for this file name, please handle it POSIX-like, which in particular means it's case sensitive, because that's one of the main differences between Linux or within NFS, between NFS and SMB. SMB is case insensitive, so you can only have one file test.txt. In NFS, you can have a gazillion files test.txt with different uppercase, lowercase combination. And we can tell on a per call basis, yes, for this file name, please treat it in the POSIX way. That's long implemented. Then we want to query POSIX metadata. What is it? If you look at the stat syscall, at struct stat, there are things that POSIX knows a file that NTFS doesn't natively know. Yes, we have owning group, we have owner, and so on. We have a lot of things in common. For example, one thing we don't have is number of links, number of hard links. The POSIX permission bits, yes, you could probably hide them in whatever, an ACL, a style of ACL, but the POSIX permission bits, they are particularly hard to get, so we added them to a so-called POSIX information class. I'll talk about that in a minute. We have all this documented, as a protocol extension, go there. That's just a pure document. That's not code. Go there. And this is, of course, open for discussion and extensions. Coming back to this SSH agent. An SSH agent wants to open, or debug server, debug session server. SSH agent wants to create a socket in my home directory. It can't right now. And there are other cases here. For example, if you want a diskless boot, you also need block devices and character devices, and so on. You want to represent properly all these file types beyond regular files and directories. Of course, Samba, since its inception, has done files and directories, obvious. I mean, otherwise you wouldn't be a file server. But what do we do about the others? Block devices, character devices, and so on. What's a block device? What's a character device? Essentially, in the Unix world, this is a link to hardware on the local system. I open dev-SDA and I get direct access to the blocks on my SCSI disk or whatever is behind dev-SDA these days. So if I now present a block device over a network protocol, there's essentially two choices that you could make in theory. I could say, okay, I'll open dev-SDA over a network protocol, and the question is, who interprets this as a device? And dev-SDA there might still be a reason to say, okay, I open dev-SDA over a network protocol, and I want to look at the server-side hard drive. Could be reasons for it. I think it's not a good idea, but there could be reasons for that. The example I gave there, dev-null. You don't want to send the garbage you want to send to dev-null over the network for the server to just throw it away. So the idea here is that if a character or block device is presented over the network, it's only an indication for the client system to look at the local devices it has. That's the idea. FIFOs and sockets, what is that? Essentially, that's an inter-process communication mechanism for processes local on a system. Here as well, you could argue that, okay, I want to open a socket on the client, and I want to talk to the server process. You could argue that. This is, in general, not what we want to do, because, again, we want to have the SSH agent. I don't want the SSH agent to run over SMB on the server. I want to look at it locally. So my home directory needs sockets to be presented like local sockets. Same for FIFOs. We already do handle sockets as a cross-node network inter-process communication mechanism. There's a special share in the Windows world called IPC $, inter-process communication. $ means not visible. We do that for DCRPC, printing, remote registry, a whole bunch of others. We have patches pending for the Windows Search Protocol, which is not DCRPC, but raw pipes. So we already do that, inter-process communication mechanism over the network for special cases, for this share. For the general home directory, you don't want this. Then the last one, symlinks. There's, really heated discussions, and even the Rust community was hit by a symlink race. Everybody was hit by symlink races. So the question is, are symlinks a good idea overall? They are there. You could argue, no, you don't need symlinks, you don't want symlinks, just make them go away. It won't happen, we all know that. The only thing is, the server should not bother. And if you look at the NFS RFCs, symbolic links are not a server thing in the NFS specification. It's only a client thing. Samba historically has treated symlinks server-side. And I will show an example later on. We fixed that. Okay. Block and character devices, sockets, FIFOs, special types of files. So we could extend the protocol with all these things. There is a native Windows mechanism called repass points. that interestingly enough, the Windows-based NFS server also uses to represent sockets, symlinks, sockets, symlinks, and all the other ones. The NFS server on Windows uses repass points. What's a repass point? Essentially, it's a mechanism to extend functionality of the NTFS file system. What does it mean? You take a file and essentially you just create a special extended attribute on that file on NTFS. When this extended attribute exists, what happens at open time is the native NTFS implementation sees, okay, this extended attribute exists. This extended attribute then points at some DLL on Windows, dynamic link library, shared object in Linux speak. And when this extended attribute exists, essentially some function is called to take care of this, whatever special functionality for this file. Essentially, you can intercept open calls. That's what a repass point is. And this is what they used here. They have a special error message. So you set a repass point extended attribute pointing at some DLL, and that DLL is just not there. When trying to open that file, all you get is repass tag not handled, which is fair because I told the system, hey, use this whatever hierarchical storage management mechanism to open that file, but whatever HSM software was deinstalled, repass tag not handled anymore. And so this is, as I said, a general mechanism to extend NTFS functionality with some magic. MSFSCC, that's one of these several thousand lines of document. Google for this in brackets MSFSCC, and that's one of the documents that Microsoft have published. They define a few dozen repass tags, which is special extended attributes. This repass tag does that. This repass tag does this, and so on. They have defined some of these. Some of them, or most of them, are not meaningful over the wire, which means we don't document. We don't want to document them. The Windows NFS server just does exactly this. It uses repass points to represent special files, like FIFO sockets and all the others. So when an NFS client comes in and does a make node or a socket call, what the Windows NFS server does is it creates a file, it attaches a, did I name it here? Special defined repass tag NFS, one of these special extended attributes, and as content of this extended attribute, they have the major and minor device number if it's a block device. This is what they do. And they define subtypes of this extended attribute. Just look up the spec. I mean, it's pretty obvious. They have NFS symlinks. Interestingly, Windows properties shows just L for all of these, which means it believes the Windows Explorer application believes whenever there's one of these repass tags, it's a native Windows symlink. But that's just a GUI glitch, I would say. Okay. So now we have established that we want to, when a Samba server lists /dev, you will find all sorts of special devices. If you do an ls-l on /dev, the very first column is the file type. If you look at the readdir system call, which is get the ends these days, but if you look at the readdir documentation, all you get when your application on Linux does a readdir call, all you get is a name, essentially. There's more, of course, but all you get is a name. And if ls-l wants to attach nice colors to sockets and nice whatever, is a P for pipes, it has to stat every time for each of the name. Yeah, 10 minutes, thank you. For each of the name. which means round trip to the server. Because the NFS readdir call only gave names. This is why they implemented readdir plus, which already in that first run gives the attributes, the relevant attributes. SMB does exactly the same. When you do a readdir call over SMB, you can ask for so-called info levels. So this is essentially a readdir plus with like roughly maybe 10 or 15 different info levels defined with different level of detail. And what we did is we added another info level for Posix. And if you listened to all of these SMB-specific Unix extension talks, there was a hot debate what style of symlinks we use. What style of repass points we use. There's not only the NFS server, there's other applications. There's Windows Subsystem for Linux using its own repass points. And there are downsides and upsides for each of these specific ways to represent special files. And what we settled upon is we have extended our struct info level. We have extended an info level for struct stat. And this is the first thing I want to show you here, just upon Wireshark trace. So Posix readdir. Can everybody read that? Large enough. So going down. Find request. I mean, that's the way to ask for readdir information. And this is a directory with a lot of files in there. And we could probably extend Wireshark to show the name here. But what we find here is it is a file called FIFO. And that's what's missing in the summary. So I just did an ls in a directory with a FIFO called FIFO. And I mean, that's really pretty deep detail. We represent it as repass tag NFS. But the point is that CIFS client with just repass tag NFS should have asked what's the content of this repass tag to find out, is it a socket, is it a FIFO, is it a block device? And this is something that got under hot debate. And the way we just solved this is we already have Posix permissions. And if you look at normal Posix permissions, I mean, there's a few bits in that 32-bit mask left out of those 9. And we just defined, okay, we have space here. The old tactic, okay, don't really extend the protocol, just use some unused bits. And this is kind of now, that's one thing that's new since last year, that ls minus L is just as efficient as readdir plus and NFS is. That's one of the things that are new and which are, I think, a good way to do things. Okay. Symlinks. And I don't have too much time left. We have 3 ways, or I think there was even one more way. We have 3 ways to represent symlinks. One is Windows Subsystem for Linux defines its own symlinks. NFS has yet another version. And then Windows NT has symlinks. I mean, Windows does have symlinks. They also have hard links, but that's another story. They have symlinks in NTFS. And we settled on IO repass tag symlink, the native Windows way, for one specific reason. So, as I said, symlink races are present all over the place. They have been present in the Samba server side. We solved those. But we want to get rid of symlink handling in the Samba server completely. What do? When we hit a symlink, we just tell the client, I had to stop on symlink, and let the client deal with it. And there's a very nice error message, and I want to show you that as well. Nope. Okay, what did I do? I have a directory and there's a subdirectory called A, this one here. There's a subdirectory of that called B, and within that subdirectory there's a symlink that points at B. B, cdc, x.txt. What did I do? I tried to open the file a/dir/c/x.txt. Where was it? Crap. Here we go. And this is the error. So you see here, I tried to open a/dir/c and so on. That's what I tried to open this here. I hit a symlink, and what I want to point out here is this really nice error message, and I actually like that, which essentially tells me, if I could now click correctly, okay, unparsed path length. What does it mean? It gives me this error message when trying to open that file, gives me the symlink target. Remember, I pointed dir at B. It directly in the return gives me the target. It also tells me via this field where the symlink is in those path components, which means that the client can easily, just from this answer, resolve that symlink. Doesn't have to go back to the server. It can directly say, okay, the ultimate goal, the ultimate target file is this. All information there. One single round trip, symlink handling completely on the client. Server doesn't have to solve symlinks. Okay, I'm a bit in a hurry. Long-running compute jobs. I said NFS is secure. SMB is secure. You need user accounts. A long-running compute job fails on that. Google for Daniel Kobras's talk with the GSS proxy. There's some, I believe, FOSDEM talk, I don't know. Google for Daniel Kobras's GSS proxy talk. Brilliant, works today. That problem is solved. Current status. Our server side is done for all these special files. Server side returns stopped on symlinks and has the client follow the symlinks. So we can represent symlinks, we can create symlinks, we can properly handle client-created symlinks with this. Linux 6.13 has POSIX special file and symlink handling already there. Of course, bugs pending. Try to test it. The big missing piece is ACLs. And that's another kind of worms. Probably that's a talk for next year, how we deal with ACLs. So from a server side, I would say pretty much done, except for ACLs. Now we need client integration, clients doing the symlink handling properly, our libSMB client and so on. That's pending work. That's it. One minute. The question was for extended attributes. The NFS, the SMB protocol natively has extended attribute support. So that's mainly a client thing to actually make use of those calls.
And then server side is implemented?
Server side is implemented, yes. Yeah, all right.
For the different tags with NTFS and WSL and whatever, are you implementing them all and using them at runtime depending on which file system, which brand of Windows you have, or how is this going to work or already working?
Can you say again?
You have different. You showed the different tag things for WSL, which is undocumented for NTFS and whatever, and the NFS tags. Are you using them all depending on what's available in the runtime machine, or?
Question was about these different tags. Do we use them all? Depending on what the client does. So the client is free to set a WSL repass tag. And the way we do it, and this is a slide I skipped, if a client does this to us, It just creates an empty file and sets a special extended attribute. That's what it does. And we don't care about those contents. This talk is about how do we represent things we find on disk. When Samba finds a native socket on disk, how do we represent those? If you list /dev, how do you represent these things? And our decision is go with NFS. But the client is completely free to do anything. Time's up. I'm here.